Welcome back. How lovely to see you again. Today, I would like to talk about computer vision with you. But first of all, let's make clear what exactly is computer vision. The fundamental idea is we want to enable our AI to identify and to understand objects and people in images and videos. That means we want to teach the AI to see and to comprehend visuals just like us. Well, like you, I am also just a machine. Alright, sounds fun. But where can we make use of that knowledge? Honestly, there are a lot of possible applications for that. You can program your own security system, for example. Or you can observe and recognize wildlife from afar. Even autonomous driving makes use of it to recognize other road users and signs. So we see that there's plenty of potential in getting familiar with this topic. And today I am here to show you that it is pretty easy to understand and to use too. Do you know the best part? If you know a thing or two about Python, the programming language, or if you are not afraid of learning something new, then you don't even have to pay a dime. It's all freely available and not that difficult to understand. We will start talking about OpenCV, which is a famous library with a lot of functions to use out of the box. With this, I want to show you different ways of working with images, so that you understand better what the complex frameworks are doing for you automatically. Then we will take a brief look at YOLO, a popular object detection algorithm for real-time use. And in the end, we will see some examples of successful computer vision applications by Detectron. That is an easy-to-use but yet powerful framework for object detection. All of these cost nothing and merely expect you to dive in and try them out. So, without any further ado, let's go. OpenCV offers a lot of different functions to analyze or alter our images. To get to know them better, we will take a look at a few examples. Like these foxes, aren't they adorable? Now, there are a few alterations we can apply to this image to process it. Most of the time, we will start by converting the image to black and white. That means that our image is not a mixture of 3 different colors anymore. Instead, each pixel now represents a value between 0, black, and 255, white. Which means most of them are some shade of gray. This is useful because dropping colors reduces the complexity. And the diminished file size helps our AI to learn faster. With this, we can now alter the image in a few different ways. The next step will be to apply so-called image smoothing. And that will look somewhat like this. Or like this, if we want to work with it in colors. The idea is that we remove sharpness and clutter to give a much more smoother and blended effect. That helps our AI to get a general idea of what a fox looks like, no matter the details of one specific animal that might differ from its friends. Let's look at yet another example to illustrate why this makes sense. Here we see that the original image contains many details. We can distinguish almost each tree. There are snowy and rocky parts of the mountain. But we actually don't need these details to get a general idea of what a mountain, a lake, or a forest look like. And if we take a look at the smoothed image, we see that we lost a lot of information and are left with the basic shapes of our object. But for our AI, this is brilliant, because it is supposed to recognize mountains in general, not just this specific one. Alright, that was the smoothing. A similar but yet different technique is called image thresholding. Here we set a threshold and evaluate each pixel separately. You remember, right? In grayscale, each pixel has a value between 0, black, and 255, white. Now, if the value is above our threshold, it will be set to the maximum. Whilst below the threshold, it will be set to the minimum. And the result looks somewhat like this. We see that it is now far easier to distinguish the foxes from the background. And our AI can extract the foxes more easily with this representation too. But if this representation does not work well, we can always try the edge detection instead. Here, we don't apply a threshold, but rather look for strong changes of colors, in other words, edges. And if we highlight these, that is what it will look like. Again, this makes it far easier for our AI to work with and interpret our images. We see that there are now parts of the image that are more clearly visible than before. At the same time, other parts are not as clearly distinguishable anymore. So we see we have to try different things out and decide for ourselves what works best. To round things up, we will look at a completely different technique called the geometric transformation. This one is especially useful if our desired element is not centered ideally or aligned well in the image. Like the cover of this book, for example. Let's say we are interested in a shot of this cover, but only get this image. And we know that there are mathematical ways to work around this problem. So, if we give our AI a second or two to do its magic, it manages to center the cover of the book almost perfectly. Quite impressive, don't you think? With this, we can use suboptimal images and bend them to our whim. And I'm sure that you too got more ideas on how to make use of this. Okay, that is a lot to process right now. But hopefully, it gives you a better intuition of what are the possibilities regarding images in computer vision. If you do not want to do all of this by yourself, there are out-of-the-box solutions that do all of this for you automatically. Usually, these solutions are called frameworks. These frameworks comprise many features and bundle them in easy-to-use functions for you to discover. Among many others, there are two very famous ones which I want to present to you. Let's start with the first one. It is called YOLO, you only look once. YOLO is one of many algorithms to apply to images and videos to extract information. The majority of these algorithms need two steps to identify an object. First, gather a set of potential locations in the image, and second, refine these proposals to come up to a conclusion. YOLO does this in one step, hence the name, you only look once. And even though usually the one-step algorithms tend to be less accurate, YOLO manages to work really precisely and very fast. Which is why it can be used for real-time usages like security cameras. So, with just a camera, and now how about YOLO, you can detect thieves in your home immediately. And when you detect them, you can call the police, activate a water sprinkler, release your dogs. You can do whatever you deem necessary to keep your junk from being stolen. So, YOLO is quite useful to keep a second pair of eyes on your home or wherever you got a camera. The other very popular and at the same time powerful framework to use is Detectron. Detectron is developed by Facebook AI, completely free, and includes several state-of-the-art object detection algorithms. Like pyramid networks, dense pose, various variations of mask RCNN. But you don't need to know what these names mean, let alone the underlying concepts. If you are really curious, I will put some links into the description. Otherwise, we will use them without understanding them. It just works. The main takeaway is that they are sophisticated, bulletproof, and easy to use via Detectron. You have a hard time believing me? Let's watch how simple this is. First, we need to call Detectron. Say hello to my cute little friend. Then, we need an image we want him to analyze. How about this mix of dates and hazelnuts? Afterwards, we let our AI take a thorough look at it. And after a few moments, we see that it manages to identify each of these fruits. And that is just the beginning. This can be done with all kinds of objects, animals, persons. Because Facebook already put a lot of work into training the AI with their data. And if there's something new we want the AI to recognize and detect, we can train it any way we want by ourselves. So, feel free to train your model on balloons, on whole sceneries, or even complex engineering problems like this SAR example. And what baffles me the most, we do all this with just a few lines of code. Everything else is being taken care of by the framework. You now see, each one of us can become a computer vision engineer easily. And this does not just only work on images, it is possible with videos too. Look! Here we see a video of two lovely animals enjoying the sunset. And this is what it looks like after our AI did its magic. Isn't that magnificent? And with this example, we are again at the end of the video. I hope there has been something new for you among all of this. Maybe it even motivated you to try it out yourself. Either way, I'm happy that you stayed so long. I'm looking forward to see you next time. Feel free to watch my other videos about linear and logistic regression. Bye!